All right, next up we have Amartya Bhattacharya from Northeastern University here to talk about a sustainable marimba and materials to make that happen.
All right. Thank you, Hannah. It's great to be here. First off, could I actually just get a show of hands for who here has heard the marimba? Okay, cool. That's most people. That's pretty good. I probably should have introduced myself first. My name is Amartya Bhattacharya. I'm studying computer science and engineering at Northeastern University, and this is my session. So on this next slide, we have a brief sound sample. So that is the sound of the instrument that I fell in love with, and I want you all to pay attention to what the marimba is made of in this picture. Primarily the wood. So this all started a while back when I was in high school. At my school, we had a beautiful Yamaha 5-octave rosewood marimba. And I vividly remember one day fighting with my friend over who would get to practice on it first, because we both wanted to go do other stuff and we both had to practice. It was at that time I thought, it's made of wood, there's some metal, resonators, whatever. It can't be that expensive. I looked up the price of that professional marimba, and I was shocked to find that the price of the marimba was around $33,000. There is a problem with the material used in the marimba, which drives up this cost, being that rosewood is expensive. So a 4.3 octave smaller version, which is a smaller version of a marimba, made from rosewood, is around $6,000 for a introductory version, and it goes up to $33,000 with a professional version. Rosewood faces a number of issues, including illegal logging, slow growth cycles, high demand, trade restrictions, trafficking, and more. All of these things contribute to a high price, which leads to a high marimba cost. There are a few alternatives to rosewood. However, for the alternatives being primarily Padauk, a Padauk 4.3 octave marimba is still at around $5,000, making it inaccessible to many. So what? I mean, what's there to do about it? What I hoped to do was to look at the materials around me and in my environment and find out what could be used as a substitute for rosewood to make the marimba more accessible by reducing its material cost. In order to do that, I gathered 17 materials, including plywoods, plastics, and the bulk of the materials used being American hardwoods, and I evaluated them on 3 parameters. The first parameter is the density. How tough is the material? The method to play the marimba involves taking 2 yarn mallets and then hitting it. So if you hit it every day, a lot of times, you really got to make sure that it's a strong enough material to be able to withstand that and not crack, so that it has to be replaced. Then we have Young's modulus. Young's modulus is a measure of the stiffness of the bar, and practically here it represents the feel of the bar, and it also works to convert the kinetic energy into sound, giving us an equation for the frequency. Finally, we have the sustain, or the loss factor. How long does it ring out? After you strike the bar is going to ring for a little while. This is essential for marimba techniques like rolling, and to give it its characteristic sound, especially in its lower register. So, here is how I evaluated the materials. First, for the density, the materials were cut into rectangles or put into rectangles. I measured the length, the height, and the width. I put it on a scale, divided, done. Then we had to get the Young's modulus and the loss factor. So in order to do this, what I did is I took the wood and I suspended it by its nodal points, or points of no vibration. This means that the wood would basically be vibrating as if it were in a vacuum, kind of, as if there were no other forces acting on it. So the wood was placed over its nodal points. The sound was recorded by the setup shown in the bottom figure, and the frequency was analyzed to get the fundamental frequency. This was able to be used in conjunction with the dimensions of the bar and the density to be able to find the Young's modulus, and some of the sound sample, the FFT of it, which is the frequencies, was used to find the loss factor. And we have all of the materials used pictured at the top here. Now we have the exciting part, the results. So for the first slide, we have the density, which represents the strength of the material. If you want spoilers, you can look at the arrows. If you don't want spoilers, you can just pretend they're not there. As you can see, we have rosewood in the brown. A number of materials did pass and met our criteria for density based on a historical precedent for marimbas in Southeast Asia. We had a number that were okay, and we had only a few materials that actually completely failed our density measurement, which was good. You want a lot of materials that pass these requirements. Then we have our Young's modulus to density ratio. The reason this is significant is because when you solve for the fundamental frequency, you end up with Young's modulus over density. So this ratio essentially says that if you have a rosewood bar and something like walnut with that same ratio, 2 bars of the same size made from the different materials will have the same pitch. Like 2 C bars would be the same size for rosewood and walnut. Again here, sadly, more materials are getting eliminated, more are gone, but there's still a fair number in this middle band that meet our threshold range. Finally, we have the real issue with many of these materials, being the damping or the loss factor. A lot of them do not like to ring out, and this is the result that we got. So as mentioned before, padauk is sometimes used in marimba construction, and it was the one material that passed our original criteria for measurement, which is good. That means that this method should be reliable. However, given that nothing passed the initial parameters that we had, I ended up expanding my parameters a bit to get an idea of what could work in the future. And that gives us our 2 materials as our successes. We have our runner-up being cherry. Cherry had a great Young's modulus to density ratio, so cherry bars and rosewood bars would be the same size. The damping isn't as good, but none of the materials tested were. However, the primary issue with cherry that makes it a less suitable candidate compared to other materials is its density. It is a less dense material, meaning it's weaker, it's going to have to be replaced more often. Then we have hickory. Hickory was our winner. Hickory has an almost identical Young's modulus to rosewood, so its stiffness is the same. It'll feel very similar and respond very similarly to rosewood. It has a density higher than padauk, so that precedent for density has already been set, and it's surpassing that. And it was the closest natural match of any wood tested, which was fantastic. So, why does this matter? What actually is the price disparity? Per board foot, which is a measurement of a square, which is a foot square, that's 1 inch thick, we have Honduran rosewood at $53. Hickory, on the other hand, is only $8 per board foot, and cherry is $6.20. This could have an impact in allowing low-income school districts to afford a marimba for the first time. It could allow student percussionists to finally stop fighting over the few instruments at their school, and it would mean that the marimba itself is less reliant on a wood that's facing these challenges and is more accessible to many. Thank you.
We'll do some questions.
All right, thanks so much. We'll start with questions in the room. I'll pass it from back to front while we wait for our live stream participants.
I have one sort of half question, half comment. Listening to your presentation, I was thinking about the board game Go. I don't know how familiar with it you are, but in Go, the most prized Go boards are made of kaya wood, which is renowned for the sound that it makes when you play the stones on the board. But kaya wood, similar to rosewood, is incredibly rare and expensive, and so most commercial Go boards are made of spruce, which is still good but less ideal. I was sort of wondering if you had any plans to maybe expand this type of research into either Go or maybe some other fields where there's this sort of extremely rare but highly prized wood that might have alternatives that haven't been investigated?
Yeah, so I don't have, or well, I didn't until you said that, have any plans to investigate other woods facing similar issues. However, I think that the methodology present here could be transferred to these other fields pretty successfully. So maybe after this, that's something I will consider. That's a great idea. I didn't know that the Go boards were made of a special wood. Thank you for sharing.
Yeah, absolutely. Thank you.
Great talk. I remember fighting over marimbas. My question's on your Young's modulus and a little technical. You had it in the shoebox, but on a marimba itself, right, the keys are all lined up next to each other, which would cause a little bit of reverberation, and it's the pipes underneath. Do you think the Young's modulus setup that you did was affected at all by the different material and the more airspace around the boards?
I suspect that it probably did have an effect on the Young's modulus, yes. But I think that given all of the materials were tested with the same setup and viewing it kind of as an exploratory study to see what could be successful versus super technically what is definitively perfect, I think that's actually very fair. And now that I'm at a university and not in my basement at high school, I think I might be able to expand on that and get more precise readings. So Thank you for addressing that.
Yeah. All right. Second small question. Are you thinking of building one out of hickory just to record them and compare?
Absolutely. So there was a study done that found that through the processes, I always mess up saying this, mechanical densification and thermal modification, which is taking the wood and squishing it and then baking it in the oven at 160 Celsius for 30 minutes, then letting it cool. You can actually alter the loss factor by 20% in a favorable direction and the Young's modulus by 10% in a favorable direction. Theoretically, this would mean that hickory's Young's modulus is actually higher than rosewood's, which is pretty shocking, it's pretty weird. And it would mean that its loss factor isn't yet perfect, but it's pretty good. And so after doing that, I would hope to make bars out of it, given that that's successful with hickory. Then test it and qualitatively evaluate its sound as compared to rosewood and other materials. That would be something I'd be hugely interested in doing. Yeah, I'm going to this summer. That's my plan.
Hi, you both answered both of my questions, but I have a follow-up. Did you use something like a vibrometer or a Doppler to measure the oscillations? How exactly are you making the measurements?
So, I would have loved to. I really wanted to. I read about it in a lot of other papers. However, due to the material constraints at the time, I was unable to. I do hope to, though, in the future go back and refine these measurements to get a more concrete reading. Laser vibrometry specifically is something I saw in so many times. Just so expensive to buy one.
We do have a few questions from our live stream audience.
Okay.
First question is, was that you in the video playing the marimba?
That was a simple sound sample, I think, from an audition I took. I wanted to get something where people could hear the instrument itself and not me just playing a million notes and people are just like, what are you doing? So yeah, that was me playing.
That's awesome. And the next question is, how does the feel of a hickory marimba compare to a rosewood or a real marimba to the player?
Right. So this hasn't yet been something I've been able to personally evaluate. However, given the similarities in the density and the Young's modulus, we can assume or ascertain that it's highly likely that they'd be similar. The values themselves, hickory's Young's modulus from my calculations was 15.66 gigapascals, and rosewood's was 16. For the density, I will go back to the slide because I have the slide. The density was the closest of any material tested, although it's a bit lower. So it's likely that the experience of playing would be similar, but there would be minor differences, like the difference between playing on rosewood versus Padauk or another material.
All right. And last question is, do you have any idea of the number of marimbas purchased or replaced each year?
That's a great question. I actually do not know. No. I think that would be something interesting to investigate. I will say, based on my personal experience, I found that bars can crack every so often. I think a bar cracked on most of the marimbas I've played on every few years. In terms of whole instruments being purchased, I think it's pretty common in new school districts or school districts hoping to expand, as well as student percussionists who are very passionate about their art and who don't face that barrier to entry. You know, instead of buying like a $150 intro guitar, spending like $3,000 or like $5,000 on a 4.3 octave, this big, you know, Paducah marimba. But yeah, one thing I do want to make clear too is that I don't think what's going to happen as a result, or what the aim of this is not to be that we go into like the Boston Symphony Orchestra Hall and throw their rosewood marimba out and replace it with the Hickory one. I think that the thing to me that's really interesting and exhilarating would be making the marimba just more accessible to people who want to practice, who want to elevate their skills, and just having more people get involved with tuned percussion and mallet percussion. I think it's a really great thing that I love and enjoy that I would love to share with others.
Wonderful. Thank you. And I'm sure I'll thank you on behalf of all the percussionists I know.